Hello. Video, we are going to talk about 1.1 parametric equation. So let's take a look at the concept. So what is a parametric equation? So in this section, we're going to examine what the parametric equations are and how to graph them. So in general, if you remember, parametric equations are useful for describing curves that are not necessarily function. So what I'm saying is there are three different variables to find out the parametric equation. So what is a parameter? So let's say you have a function x and t, and each function is described, or it's going to be written in terms of the t variable. So x and y functions are depending on t independent variable. So we call that t as a parameter. For example, the variable x and y is going to be changing depending on the t variable. So I will say, so for example, I'm gonna show you the graph. Let's say we have a y-axis, we have x-axis. So let's say we have x function is going to be 2t plus 1, and then y function, actually I'm going to make a parenthesis. So x function is going to be determined depending on the t variable. So t would be the input, so that depending on the t, you will get the output of the x function. Same thing, let's say you have a y function that is in terms of t. I don't know, I'm just creating randomly 2t. So what happened is, let's take a look at it. We have three different variable x, y, t. So depending on t, you see that? So t, if it is 1, the x function is going to be x of 1 will be 2 times 1 plus 1 will be 3. And then y of 1 is going to be 2. So when t equal to 1, you will find out 3, 2 from x and y function. So you can keep on doing like that. So let's say you keep on doing this, and we're going to find out like kind of this function. We call this graph is a parametric equation. Okay, parametric equation, or we call this is parametric curve. Because sometimes you could find out like a quadratic function or a little bit of trigonometric function. So depending on the t, you will find out a variety of parametric equation that could be curve or plane. So here we have a t equal to 1. That time it's a 3, I don't know, I'm just going to go to here, t equal to 1. It is, let's say, 3, I'm just approximately graph it, or t equal to 2. So your graph is going to be something like that. Okay, so we call t is a parameter, which is a very independent variable, and both x and y functions are relying on the t. Over the time, the x and y function is going to be changing. Okay, so if you find out that graph, that's how we call parametric equation. Depending on the shape, it could be parametric curve or plane, depending on 2 and 3 dimensional space. Also, depending on the textbook, we also call the parametric equation as a Cartesian equation as well. Okay, so there are a couple terminology I just introduced in 1.1. It's not that complicated. You have two functions x and y, and they are really depending or relying on the independent variable t. And then as a t is changing, x and y functions are also changing. And then if you can graph it like that, we call that as a parametric equation or curve, parametric plane, depending on the shape of the graph. Okay, so we kind of like understood the concept of parametric equation. I'm going to take a look at more detailed example, and then let's try to sketch the curve of a parametric equation. So let's go down slowly. So here exactly, I'm going to give you x and y function. And as you see that each function is relying on t. As a t is changing, your x and y will be changing. So let's take a, let's create a graph. So let's say your t is actually between 0 and 4. So I'm going to make a graph. So here, if t is a 0, 1, 2, 3, up to 4. And then I have x function is t minus 2. And y function is a 2t minus 1. We can fill out this table. If t is a 0, the first one is going to be -2. Keep plugging in 1 when t is a 1. It's going to be -1, 0, 1, 2. If t is 0 in terms of the y function, it is going to be -1. It is going to be 1. You're going to plug in 2 times 2, 4 minus 1, 3. And this is 5 and 7. So what does it mean? When t equal to 0, your coordinate point of x and y, it is going to be -2, -1. When t equal to 1, you will find out the position at -1 and 1. When t equal to 2, 0, 3, and the next one, 1,5, 2,7. So let's really graph it. I have -2,1 here, -1,1 here, 0,3 here, 1,5 here, 2,7 here. So I'm going to graph it. So if I do the graph, it's going to be very linear. So let me just graph it a little bit clear. So let's say this is 2, -1. So you see that? This is the linear, and then we call, what is that? Parametric equation. We don't know what that is, but in this time we check, this is the linear graph. So that would be y equal to mx plus b form, because it is a linear when you check the graph. So we can point out here, this is a -2, -1. This is when t equal to 0. This is -1,1 when t equal to 1. And then this is a 0,3. This is when t equal to 3. This is when t equal to 3. This is when t equal to 4. So this is how you're going to graph parametric curve or parametric equation from the given x and y function. Does it make sense to you? So it's not that complicated, very makes sense. I'm going to show you later how to find out that equation. But so far, I want you to really understand the relationship among x, y, t, and how to graph it. Okay, so over the time, as t is changing, your x and y function is also changing. Your coordinate points are changing as well. Okay, so let's try to one more example. Sometimes you might not find out the linear graph. Sometimes it could be the quadratic shape or trigonometric shape. So let's take a look at the second example, letter B. I'm going to do the same work. So t, -3, we have a specific interval, -3, -2, -1, 0, 1, 2. And x function is determined 3t plus 2. Actually, I'm going to move this one here. And then y function is a determined t second power minus 1. So you see that we can fill out the table. So let's take a look at the table and let's fill it out. You can simply plugging in -3 times 3, -9 plus 2, so -7. And then if you're plugging in -3 to the y function, it's going to be 8. You can quickly calculate all the rest of, empty box. This is a -4, 3. This is -1, 0. This is a 2, -1, 5, 0, 8, and 3. And then what we're going to do, we're going to graph it. So I'm going to actually minimize this part. And then I'm going to minimize this as well. Okay. So actually, I'm going to bring this table to here. Before I'm going to do, I'm going to get rid of it. So let me try it again. So this was the example 1, right? And then I'm going to get rid of it. Are you okay with that? So we are doing the second one. So what does it mean? When t equal to -3, you have coordinate points at -7, 8. This is when t equal to -3, -4, 3, da 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 da. So let's graph it, and I'm gonna see the shape of the graph. So when t equal to -3, -7, +8, all the way up. So this is when t equal to -3. When t equal to -2, we have a -4, 3 around here. So this is a t equal to -2. And then when t equal to -1, -1, 0 right there. When t equal to 0, 2, -1. And then when t equal to 1, everything is a positive, so 5, 0. And then t equal to 8 is going to be 8, 3. So when I graph it, this is going to be something curvy, which is not linear. So this parametric equation looks like a parametric parabola shape. Parabola shape. So it is going to be something y equal to x second, ax second, bx plus c4, which is not linear. So I just want to, I just wanted to show you when you graph the parametric equation, sometimes you can find out the linear, right? Sometimes you're going to have a little bit of curvy parabola shape. We don't know what kind of graph you're going to find out. It's going to be a lot, it's going to be very, diverse. But in this example, I'm showing you linear and parabola shape, okay? So this is how you are going to understand what the parametric equation and how to graph it, okay? Very traditional way of finding parametric equation. Now, I really want to find out what this equation will be, right? I really, really want to find it. So I'm going to keep going to find out that equation. But so far, you guys understood how to graph it. So this is how to graph it. Now, let's take a look at example 2. I want to find out the Cartesian equation. So specifically, Cartesian equation is going to be same as parametric equation. In this time, we are going to identify what that is. Okay. All right, let's take a look at the example ABC one more time. So look at letter A. Now you can graph it. So let's graph of the first, two functions parametric equation. So you can do, I'm going to give you guys a specific interval. Let's say t is between -2 and +3. So t equal to -2, -1, 0, 1, 2, 3, right? And then x function is a 3 minus t. Y function is a 2t minus 3. So I know you guys can fill out this table. Let's do it. So when you do it, it's going to be 5. It is going to be -7, 4, -5, +3, -3. I just plugging in 1 into each x and y function. 2, -1. When t equal to 2, when t equal to 3. So you can graph it now, right? So we do have x and y axis. So these are the coordinate points. So 5, all the way -7. This is when t equal to -2. And then when t equal to -1, 4, -5. This is t equal to -1. 3, 3, -3. This is a t equal to 0. 2, -1 right there. And 1, 1, right? So we can have a 1, 1 and 0, 3. So if I graph it a little bit, I think a little bit mistake here. This is a t equal to -3, 5, 7, -7. 4, -5, 3, so 3, let's say 3, -3, 2, -1 here. It should be linear though. So I actually graph it a little bit better. So you can actually graph it. The last one is a 0.3 right there, 0.3. So if you graph it, it's not gonna be like curvy. Exactly, this is going to be something like that. This is a linear, okay? So when I graph it, I point out all the coordinate points. So this is the graph, right? So this is going to be linear form, linear shape. And then I want to find out the specific parametric equation of it. And then since it's a linear, it'll be y equal to mx plus b. I want to find out this graph, the linear. How to do that, right? So here is the couple method, but I'm going to show you the simplest method that the textbook introduced. You are going to use the given two function. So x equal to 3 minus t, you can simply say x equal to 3 minus t. And then the second function is, you can simply say y equal to 2t minus 3. I'm going to modify the first function in terms of the t. So you can solve for t, then what happened? It is going to be t equal to 3 minus x. So if you have x equal to 3 minus t, I'm going to subtract 3 on both of sides. And then you have equal to negative t and divided by, negative. So t equal to 3 minus x. Now you are going to plugging in this into the t spot because they are going to be the same information, correct? So let me minimize a little bit. So you're going to plugging in t equal to 3 minus x into the second function. So then y equal to 2 times 3 minus x minus 3. You're going to use a distributive property, 6 minus 2x minus 3. And then y equal to negative 2x plus 3. Gotcha. That's the linear equation of this parametric equation. So what does it mean? We just found out this is a linear parametric equation. Literally, if you're plugging in 5, you will get negative 7. If you're plugging in 4 into that equation, you will get negative 5. So this is the linear parametric equation we just found out from the given two function in terms of the t. Okay? So I'm showing you so far how to, determine parametric, equation, by graphing it and by using the substitution method. So it's not going to be really crazy work. So it should be fine. Okay. I'm going to keep practicing like that. So the answer is going to be y equal to, this is y equal to negative 2x plus 3. Let's try one more example. I'm going to make a space. Let's try letter B. Letter B, so this one should be actually B. This one should be C. So same thing. In this time, the question is, okay, find the parametric equation of x of t equal to 3t plus 1 and y of t equal to t second minus 4. So we know that when you create a table, you're gonna find out the graph. But I'm gonna omit that process for a second because my goal is anyway find out the parametric equation. I know you guys can find out the graph, right? But we don't need to because this substitution method gonna help us to find out the parametric equation in a shortcut. So let's take a look at that. What we're gonna do. Same thing here. I'm going to rewrite it. This is x equal to 3t plus 1. This is y equal to t second minus 4. I'm going to, solve for t from the first equation. So x minus 1 equal to 3t. You're going to divide it by 3. So x minus 1 over 3 equal to t. So you're going to plugging in this one into the second equation. So that y equal to, now t is x minus 1 over 3 to the second minus t minus 4. So let's solve it. Y equal to, what happened? You're going to expand it. So it is going to be 1 over 3 second x minus a second minus 4. So basically 1/9, x minus 1 second minus 4. This is a quadratic. So what does it mean? When you actually graph those two x and y function, they're going to parabola shape, right? And that equation, we just prove it, y equal to 1/9, x minus 1 second minus 4, specifically where the vertex point at 1, negative 4, that's how you read it. And then it's the slope is positive. So it's going to be, you can graph it, 1, negative 4 is right there. So approximately you can graph the parametric curve of that function. Okay, this is a parabola shape. So you can take a look at B, and then that's the solution. Does it make sense to you? So I'm going to hold up here. It's not like too much work. We understood the concept of finding parametric equation. Traditionally, you're going to create a table, and then you can see visually how the graph look like, but that doesn't mean that what the parametric equation is. So to find out the parametric equation more specifically, I'm using the substitution method. So I found that when you graph it, it's going to be anyway parabola shape, and then that's y equal to 1/9, x minus 1 to the second power minus 4, where the vertex is 1, negative 4, slope is positive, so it's open upward, and then the vertex is 1, negative 4. So you can actually compare with your graph, the table that you're going to create it, and then it's going to be corresponding to each other. So it's going to be shortcut, right? You don't need to create a table and fill out the box. Simply, you can find out the parametric equation more directly. Okay. So I hope it's getting better and better. I'm not, giving you too much fancy work. It's a pretty understandable topic. I'm going to try to show you one more example. So we can try letter C one more time. So I'm going to make a space here. So what happened? We're going to find, so this is a C. We're going to find the parametric equation. What is a given function? When x of t equal to 4 minus t, y of t radical t, and t is a positive. Okay, we got the concept. So that's a question. I'm going to make it a little bit smaller. So I'm going to resolve it, right? We're going to rewrite it. That means x equal to 4 minus t. So you can solve for t. So x minus 4 equal to negative t divided by negative. T will be 4 minus x. And then second equation, y equal to radical t. You're going to plugging into the second equation of the t function. So now y equal to radical 4 minus x. What does it mean? This is going to be your parametric equation. And then you can create a table, right? And then there exactly 4, 0. That's how you're going to graph it to the left side. So this is the parametric equation. In this time is a radical function. Okay. So as I mentioned at the beginning, the parametric equation could be a linear form, quadratic form, polynomial form, or trigonometric form, or radical form, right? Because your function could be a variety of the shape. So therefore, letter C is much simpler. And then, same thing when you graph it from the table, you can graph it, and then you will see this graph, and the name of this parametric equation is y equal to radical 4 minus x. That's it. Okay. So I hope this is getting better and better. How you feel? So far, so good. So now I'm going to show you more complicated, example of finding parametric equations. So let's keep building your confidence of solving more challenging questions. So I'm going to keep going. A little bit challenging question. Ooh, so in this time, I'm gonna give you guys a trigonometric function, x and y. And then as you see that, those x and y functions are relying on the independent variable t. I wanna find out the parametric equation. So same question. So you could try, you're gonna create a table, right? As a t changes, x and y is changing. So you can create a table, then you can graph it by pointing those coordinate points, but it takes a long time, right? It takes a long time. It's not really efficient way to find out. So we are going to use either substitution method or think about a little bit of a identity, mathematical identity. So instead of this, we are using shortcut. In shortcut, you can use substitution method as I just showed you in example 2, or we're gonna use some mathematical identity. Okay, so I'm gonna actually bring those strategy here. Does it make sense to you? This is a very traditional way. And then the second one is a shortcut. So shortcut, substitution method, we just solve all the example 2. And then another method, I'm going to show you utilizing mathematical identity to find out the parametric equation. So all of this work is to find parametric equation. Am I correct? It could be linear, it could be quadratic, whatever, right? So I'm not going to use a traditional way, create a table, fill out the box and graph it. Takes a long time. So in this example, let's look at it. So if you want to use a substitution method, well, x equal to 2 cosine t, it's not really, make sense to solve for t. So in this time, we're going to utilize the trigonometry identity. So here, we're going to use trigonometry identity. One of the identities is, if you remember, sine secant x plus cosine secant x. If you remember long time ago, it is always 1. So I'm going to utilize this mathematical identity in trigonometry. So what are we guys going to do? We know in letter A, x equal to 2 cosine t, y equal is 2 sine t. Now, let's find out x second. So 2 cosine t to the second. Y second is 2 times sine t second power. So what does it mean? I can modify this since we know x second plus y second is 1. Therefore, this is going to be 4 cosine second t. This is going to be 4 sine second t. Should be also 1. Does it make sense to you? Are you guys okay? So let's identify what's going on. So x second power plus y second power, we know that is 1. And then we just know x second is 4 times cosine second t, and y second is 4 times sine second t. Now I'm going to combine, find out the common factor, cosine second t and sine second t. Does it make sense? I just find out the factor out 4. So what does it mean? We just got it. This one, cosine second t plus sine second t, what is it? That is going to be 1. So x second plus y second, it's going to be just 4. 4 times 1 is 4. So that's your answer, because parametric equation only it contains x and y variable. There's no more t, right? So if you go up, the definition of the parametric equation, we don't have any more. When you graph it, there's no more t. Every equation, when you look at that, the first equation, there's no t. Your linear equation is y and x only contains. Your equation only contains x and y and x and y. So therefore, We just found out. So what does it mean? These two functions, if you graph it in terms of t, they're going to create a circle. So this is a circle function. So this is the circle function where at center 0, 0, radius is 2. Because the circle equation, if you remember, x second plus y second is equal to r second power. So that's your answer. So letter A, we just described the graph. So the parametric equation of A from, of those two x and y function, it's going to be circle equation. And then exactly center at 0, 0, the radius is 2. We just describe it. So that's how you do a little bit complicated functions to find out parametric equations. Got you? Yay. So we're going to keep going, letter B and C. I'm going to keep going. Maybe you could try that, but let's try it together. Okay, letter B, I'm going to change the color. So letter B, same thing, right? You feel like circle going. So x equal to, this is a trigonometry. So x equal to 3 sine t. Y is simply 2 times a cosine t. So I have a little bit typo. There is a, cosine t. Okay. And then I'm going to just use the same identity. So the identity is sine second x plus cosine second x equal to 1. So this is trigonometry. So therefore, x second will be 9 sine second t. Y second is a 4 cosine second t, correct? So you can combine them because x second plus y second, if you combine 9, what happened? 1 second, this is a little bit ugly because I want to solve sine second t plus cosine second t is going to be 1. So before we're going to do it, we have to do one more step. Let's divide it by 9. So x second over 9 will be sine second t, correct? And then y second over 4, that's a cosine second t. So now we can adding those two because that's 1. So what happened? X second over 9 plus y second over 4, that is sine second t plus cosine second t. Therefore, x second over 9 plus y second over 4, we just proved that that is 1. So that's the answer. This is not really circle. This is ellipse equation, if you remember. This is ellipse shape, right? And that's the parametric equation of that answer. Parametric equation. So where the ellipse means if you have the longest radius is a 3 horizontally, so 3, -3. And then the shortest radius is a positive to negative. So ellipse is it's not equal length. So this is the equation of ellipse shape. Okay, where, the center is 0, 0, and one radius is a 3 horizontally, and another radius is a 2 vertically. Okay, so that's your answer for letter B. You can find out the same graph by using the traditional method. You're going to create a table, fill it out, and then point out exactly to graph it, but it takes a long time, right? So therefore, we are using here mathematical identity so that you can find out the equation and shape more efficiently. Okay, so that's a letter B. Are you okay with that? Okay, one more, letter B. Okay, so I'm going to write down the question. So let's take a look at it. We are going to find the parametric equation, right? So everything we are finding parametric equation. So the C, the given x of t equal to sine t. Y function is a cosecant t. And then t is between pi over 2 to positive pi over 2. So here, what are you guys going to do? Simply x equal to sine t, and then y equal to cosecant t. So whoa, 1 second. according to trigonometric function, you remember, right? Sine means sine function is 1 over cosecant. And then you can reciprocal cosine is 1 over secant. Tangent x is 1 over cotangent. Same thing, cosecant is 1 over sine. This is all 6 trigonometric function you already learned. And secant x is 1 over cosine x. Cotangent x is 1 over tangent x. So this is you already learned. So therefore, what happened? We have a cosecant right there, right? So cosecant is the same as 1 over what? Sine x. And now here we're going to use both trigonometry identity and substitution. I'm going to bring x into here. So that is 1 over x. So what happened? Y equal to 1 over x. This is the equation, parametric equation of those two functions. And then the graph is going to be symmetry. You can find out the same graph by using the traditional method, right? Create a table, fill it out, and graph it. So that's the equation. Y equal to 1 over x. Okay, so it's getting better. I like it so far. All right, are you guys okay? So I'm gonna hold up, take a breath. How you feel? Everything is going well, okay? So I'm showing you, many problems you can think and practice with me, and then definitely here are a couple strategies you can utilize it. So let me go up one more time. I show you traditional way, but also, there's a little bit of, limitation, takes a long time, taking a long time to find out the parametric equation. So either using substitution method or mathematical identity for complicated function, this is going to be much helpful. Okay, so let's practice one more. So we are keep finding parametric equations. Another name is Cartesian equation. So that means the same parametric equation in terms of only x and y, right? So here's a two function. And in this time, they're using parameter s. Doesn't matter, it could be t, it could be k, whatever. I want to find out the parametric equation. Well, you could try to, table and fill it out, then you can graph it. I'm not going to use that way. We're going to use, shortcut. So first of all, I can say from in this equation, x equal to 7 cosine s, and then y equal to 7 sine s. You can divide it by 7 on both of sides. So x over 7 equal to cosine s, y over 7, that is a sine s. Okay, and then we know the identity, what? We know sine secant x plus cosine secant x is 1. So we're gonna square both sides. So x secant over 49, that is a cosine secant s. Y secant over 49, it is a sine secant s. So we can adding them up. What happened? X secant over 49 plus y secant over 49, that is a cosine secant s plus sine secant s, that's 1, right? These are gonna be 1. So 49 y secant over 49 is 1. I can multiply 49 everywhere, here, here, here. So what you gonna get? Let me minimize a little bit. So then this is going to be x secant, y secant, 49. So this is your parametric Cartesian equation. This is a parametric equation. In this time, we found out the circle. Center, right? Center is 0, 0. And then radius, so x secant plus y secant 49. Center at 0, 0, and radius is a 7. That's your parametric equation, circle function. Okay, so we got this concept. How you feel? Okay, All right, so far we practice, very understandable topic. Now I'm gonna move on to the second topic. So in this example so far, the two functions were given, x and y, and we were able to find out the parametric equation. Now let's think about a little bit of backward. What if we would like to start with the equation, parametric equation, or equation of curve, and then you want to find out the x and y function. So we used to have x function given, and then y function is a given, and then we were able to find out parametric equation. In this time, I'm gonna give you parametric equation first, and then can you find out the two x and y function? Let's think about the backward, okay? So here is a couple strategy. We call that process. The parametric equation is already given. In other words, a Cartesian equation, parametric equation is already given. And then you want to find out the x and y function. That process we call parameterization of curve. So that's how we call, okay, parameterization of a curve. So here is an example. You see that? I already have, this is Cartesian equation. Sorry, Cartesian equation. And then I want to know what the x function, what the y function was. Okay, so just be aware, we have a complete freedom in the choice of the second parameterization. The only thing we need to check is there is no restriction imposed on x. That is, the range of x of t is all real numbers. So what I'm saying is, to find out the x and y, two function, okay, you have 100% freedom to choose whatever it could be. So what I'm saying is here, I'm gonna just x equal to t, because anyway, I'm gonna substitute x into the second equation. So if x equal to t, the second function should be 3t minus 5, isn't it? Because you're going to plugging in x equal to t here. So automatically y equal to 3x minus 5. We found out the same Cartesian equation. Does it make sense to you? So you can find out, couple infinite number of the, two x and y, pair of the function to find out the same parametric equation. So let's take a look at it. So in this, I'm going to just create a table. If you have this two function as your, set up the equation for x and y, let's say t equal to -2, -1, 0, 1, 2. X function is now t. Y function is a 3t minus 5, isn't it? So if you fill it out, what happened? This is going to be -2, -11, -1, -8, 0, -5, 1 and -2, 2 and 1. So that's your table, okay? And then when you graph it, it is going to be linear. So -2, -11, something here. So all the way up, this is the graph. Y equal to -3x plus 5. Are you okay with that? Actually, let me graph it again. They're going to pass into the y-intercept. This is the graph. Y equal to -3x plus 5. Okay. So we just found out one pair of x and y function. Are you okay with that? Okay. What if you want to try another x and y? Yes, you can choose another one. So in this time, second one, you might want to say, because we have a complete freedom, you can choose another one. X equal to what if 2t, right? And then you say, you're going to plugging in this one into here. So y function, 3 times 2t minus 5. So y equal to 2. 1 second. Yeah, I'm going to plugging in here. X equal to 2t, right? And actually, I'm going to solve for t, my bad. So here, before we're going to substitute, x over 2 equal to t. Okay, so now you're going to plugging in this one here. So y equal to 3 times x over 2 minus 5. Yeah. So if you do that, what happened? Uh-oh, 1 second. I have a little bit of confusion. So let me just get rid of it. Right? Because we already know y equal to 3x minus 5. So I'm going to plugging in this one into here. So watch me what happened. So you have also here x. So let me just clarify. So what I'm saying is the second function I fixed y equal to 3x minus 5. And then I changed the first equation. Okay. One is x equal to t. Another one is x equal to t. So anyway, in the first case, we found out y equal to 3x minus 5 as the same parametric equation. In the second case, it's y equal to 2t. So let me plugging in 3 times 2t minus 5. So y equal to 6t minus 5. So this is your second equation. Okay, so we have x equal to x function equal to 2t and yt is 6t minus 5, right? So this is your second pair. And then first one, x of t equal to t, yt equal to 3t minus 5. So this is your another pair. So let's graph it. I'm going to just show you what I'm saying is. So if you're plugging in -2, -1, 0, 1, 2, just plugging in random. And then in this time, x is 2t, 6t minus 5. So fill it out the table. You should get -4, -17, -2, -11, 0, -5. And then 1, it's going to be 2. And then it's going to be 1 and 2, 4. And you will get 12 and 7. So what I'm saying is, do you see that? Same number. We have, in the first case, you have 0, -5, -2, -11, 2 and 1. Same thing here. -2, -11, 0, 1, -5, 2 and 1. They are same graph. They're anyway same graph. Just the term is going to be longer. So therefore, you will get the same graph. Y equal to -3x, -3x. Sorry, this is positive 3x plus 5. So they're anyway same graph. So what I'm saying is, this is your answer. We found out the x function, y function, and then it could be a lot. You could find out infinite number of the set of x and y function. In this time, I'm just showing you 2. You can find out the third one, fourth one that are going to be same, that gives you the same graph of the y equal to 3x minus 5. Okay, so that's how we are doing the backward. In the previous concept, the x and y function already given, and then you were able to find out the parametric equation by using substitution method or mathematical identity. In this concept, we're doing the backward. Parametric equation is already given, okay? Or we call Cartesian equation is already given, and then you're gonna find out what the x and y function were, okay? So that you're gonna fix the given parametric equation as one of the function, and then you can change another, x or y, and then check it out the table and then fill it out. You can find out the infinite number of the x and y function. That's it. Not that complicated at all. Okay. So likewise, I'm going to practice a couple more so that you can understand what we're actually doing in this topic. Okay. So the answer in this example, we found out this one set and the second set. These are all the possible x, y function that gives you the same parametric equation, y equal to 3x minus 5. Okay, So let's take a look at one more example. So same thing. Ooh, you see that? I am already giving you the Cartesian equation or parametric equation. So by, thinking of parameterization process, I want to find out what the x and y functions were before you get this parametric equation. So what are you guys going to do? You can fix this one. So x, t, y, t. I'm going to say this is a t second plus 2t. I fix it. And then you can choose a t. Doesn't matter. You can choose 2t. You can choose a 3t. You can have a many option. If I choose a t, what happened? Automatically, this is x equal to t. This is y equal to t second plus 2t. You're going to plugging in, y will be x second plus 2t. Exactly, you will get the parametric equation. You can choose another. So this is a one pair, x equal to t, x equal to t second plus 2t. This is a one answer. Another possible answer, you can choose 2t, right? And then another function fixed, t second plus 2t. So x equal to 2t, right? And then y equal to t second plus 2t. So what are you guys gonna do? You can plugging in. Yeah, you can plugging in. What are you guys gonna do? You can plugging in the x, and then you can do solve for x over 2 is a t. So this is going to be y equal to x over 2 to the second plus 2 times x over 2. So y equal to x over 4 plus 4. If you graph it, you will get the same graph. So this is another possible set of your answer. So it's a very simple. You're going to keep changing one of the variable at t, 2t. Anyway, they're going to give you the same graphic. Okay. Same idea. The next one. What do you guys think? So I'm going to graph it. So this one here, a little bit we can think about it. X second plus y second. This is actually ellipse. This is ellipse shape. So x second plus y second over 4 equal to 1. You can think about this is corresponding to sine second t plus cosine second t equal to 1, right? So what does it mean? X second should be same as a sine second. Y second over 4 is the same as a cosine second t. So what I'm saying is x second is the same as sine second t. So that means x equal to sine t. Y second 4 equal to cosine second t. That means y over 2 is the same as a cosine t, correct? So what are you guys gonna do? That's your, right? Then now this is your possible answer. X of t equal to sine t. Y of t. I can solve this one. Y equal 2 times cosine t. So yt 2 times cosine t. This is your pair to get this parametric equation. You can find out more, but this is the simplest one. Okay, so think about it. It's not really complicated. Just we are doing the backward. Okay. All right. So the next one, I'm going to do the short problem. So far what we have learned, and then in this applicational problem, you can find out all the information. Okay. So let's do this work. So 2 x and y function in terms of t is given. All right, letter A, B, C, D. Find the position when t equal to 3. So simply, you're going to plugging in x of 3, 3 minus 1, 2, y of 3, 9 minus 2 times 3 is a 6, 3. So we have the object in this context is at 2, 3 when t equal to 3. Does it make sense? Yes. Let's move on B. What time does the object pass through the point 4, 15? So this is x and y. So you can say x equal to t minus 1 equal to 4, right? And then y t second minus 2t, that is a 15. So we're going to solve for t. So we're going to solve for t when. So they're asking the time t. So for the first equation, if you solve it, what happened? This one, t will be 5. Okay. So we need to check here. If you t second minus 2t equal to 15, find out the binomial factor. So t 3, t and 5, this one minus plus. So one is a -3, another one is a 5, but we already find out 5 and here corresponding 5. So when t equal to 5, you will find out the 4,15 of the position. Okay, good. C, does the object pass through 6,39? So we're going to solve it. X minus, so x equal to 6. So t minus 1 equal to 6. And then t second minus 2t equal to 39. We're going to check. So for the first one, this is going to be t equal to 7. So when t equal to 7, x is going to be 6. It's a possible. How about the second one? We're going to solve it. T second minus 2t minus 39 equal to 0. Can you factor out? We cannot factor. And then there's no way when you're plugging in t equal to 7, it's not going to be 39. So we cannot factor, and there's no t equal to 7 in the second equation. So in this answer, there's no t. So the answer is there is no t that gives the point at 6,39. We failed. Okay, so very simple question. D, find the Cartesian equation. So we know how to find out the parametric equation from the given x and y. So what are you guys going to do? I'm going to change the color. So x equal to t minus 1, y equal to t second minus 2t. So we can plugging in x into the other, or now here we have to solve for t first, right? So t equal to x plus 1. Now you're going to plugging in here. So that means y equal to x plus 1 second power minus 2t. T is also x plus 1. So we're going to expand it. Y equal to x second plus 2t, 2x plus 1 minus 2x minus 2. So 2x minus 2x cancel. So x second minus 1. This is a parabola. So this is the parametric equation. So your answer, y equal to x second minus 1. This is the Cartesian, the parametric equation. Okay. So that's it pretty much. 1.1, it's not that complicated concept. So we briefly talk about everything, how to find out the parametric equation from the given x and y, and the backward. If you already have a parametric equation, how would you be able to find out the x and y function? So we are doing back and forth work. And then one more thing I want to convey. This is not going to be in the final, but I want to briefly talk about it. There are many types of parametric function. So one of the parametric curve we call cycloid. So what the cycloid means, when you're actually, let's say you're riding a bike, and then on the straight, road, they're creating kind of like a parametric curve because the bike is a keep rolling and rolling and rolling and rolling. We call that shape is a cycloid. Does it make sense? So this is your bike, right? This is your bike. So if you keep following this radius, and then they're creating this shape, they're repeating and repeating. We call this, shape as a cycloid, and this shape is going to be given the following two function. Okay, you don't need to memorize anything. Just x function is a given 8 times t minus sine t, because this is your part of the parametric equation. So I just want to show you cycloid is a part of the parametric curve. Another one is hypocycloid. So in this case, your bike is not, riding on the straight line. You're riding a bike in a curved way. So this circle is going to be created another shape, right? Depending on the size of the radius of the circle, you could have this shape as a parametric curve, or 4 or 5. So these are all types of hypocycloid, and then that is given the following two functions. So this is not going to be in the final or exam. I just wanted to show you more example. There are a variety of the shape of the parametric equation. As I mentioned at the beginning, it could be linear, very simple, or it could be parabola shape, or as I show you, cycloid, repeating like a sine function, or hypocycloid. You could have a very special shape of the parametric depending on the size of the radius. So I'm going to just go to here, the animation I want to share with you. So let me see if I can. Yeah, so let me show you this one. So I'm gonna go back. So this is let's say this is a bike and you're rolling the bike wheel. You see that they're creating the red line. This is a parametric equation. In the bike, this is a circle function. So you have a, X and Y function that gives you this circle, and this circle created, this red. So this is another, high parametric equation you can find out. And then if I increase the radius, they're going to create more wider or narrow. So this is one example of the parametric curve, cycloid. Another one, I'm gonna show you. I'm gonna show you. I think I have a let me see. Oh yeah, here, hypocloid. So here, they're not gonna ride a bike on the straight line. Let's say, like a circle shape. We can animate it too. You see that? You're rolling a bike wheel and they're creating very interesting blue shape. This is your parametric curve when the bike is riding on the circle shape. Or you can increase the radius, right? The more large, you're gonna create very interesting shape. So there's a variety of shape of parametric curve depending on the function, okay? So that's what I just wanted to show you. You can try this. I'm gonna share this link later. So that's a hypocycloid and just simple cycloid. So you will see very, star, multiple stars, or it's a very, very, very neat, shape at the end. The more radiuses increases. So that's all about it, 1.1, okay? But as long as you can simply solve the basic question to find out like a linear, parabola, or circle shape of the parametric function, that should be enough for 1.1. So that's all about it. So this is the video that I wanted to share with you. If you haven't read the syllabus, this is time to read it. And then we have a following quiz 1.1 in the module section. That's your assignment. That's your weekly assignment. So when you watch the video 1.1, go to 1.1 quiz. And also there are more extra video you can watch. And then we do have a discussion board. This is the place where you can engage with other people, asking questions, helping each other, making a comment. That's your engaging, that's your learning environment. So that, you can help each other throughout the semester. So keep engaging. And further, if you have any question, email me. And we do have optional, meeting time. So join if you have any question, or you can email me anytime. Okay, so I will stop recording and I will see you guys in the next video. Thank you, everyone. Bye-bye.